Good morning or good afternoon to all of our attendees today. My name is Clémence Croizon. I'm the European and Africa marketing specialist for ARO, a brand of the Ingersoll Group. Welcome to the Global ARO webinar for ceramic transfer operated by the EVO Series process pump. Our goal is that during this session today, you will learn how this technology can evolve your ceramic transfer processes. Our speakers today will be Thomas Mappelli, Sales Enablement Leader Europe and Africa with 10 years at Ingersoll, along with Olof Svensson, ARO Sales Manager for Scandinavia, Baltics, and the Netherlands with 25 years in the pump industry. Please use the Q&A function on the navigation bar at the bottom of your screen if you have any question. We will answer it during the presentation or right after if needed. I turn it over to my colleague, Thomas Mappelli.
Thanks, Clémence. Hello, everyone. As Clémence introduced, my name is Thomas Mappelli. I'm Sales Enablement Leader for Europe and Africa, and I've been in Ingersoll since 2013, working in ARO since 2017. Together with me, Olof Svensson. I leave him to present himself.
Yeah, hello, I'm Olof Svensson. I'm just here today to answer any questions that might come up. So please use the Q&A button at the bottom of the screen, and we will answer, like Clémence said, as soon as we can. Yeah, welcome.
Okay, so let's start. So the objective of this webinar is to identify which could be the main challenges in ceramic applications, especially related to pumping product. Then we will see how EVO can be a solution. We will go through some success stories, and then we'll just recap on feature and benefit of EVO, and we'll open for question. I mean, it's going to be a very quick webinar. Please don't hesitate to put all question you want in the bar. So which are the main challenges of ceramic market? So ceramic market is considered an heavy duty environment. Pumps are used with a very high operating rate, pressure, flow rate. Product is a very abrasive. So any pump actually share or have in common the following points: highly hour day usage, handling abrasive fluid, and flow rate and pressure that could vary in function of the time. For example, if I think into mold filling or filter press, we know that pump is running probably fast with low pressure at the beginning, and then as the pressure increase, has to adapt the flow rate and also to keep the pressure up to the end of the process. So for those reasons, the main pumps that are the selected technology for this market are pumps that are able to provide robustness. So they need to guarantee high reliability and long time between maintenance. Gentle pumping, these products, many of those, they are mixture of different base materials. So they are quite sensitive to shear, and if handled incorrectly, they can produce foaming or bubbling. Foaming or bubbling, then at the end of the day, can cause process inefficiency or defective final product. Flexibility is also important. I mean, pump need to be able to adapt to different pressure, different flow rate, even inside the same production cycle. Low maintenance cost. We know that in ceramic, there is a lot of maintenance costs in generally for pumps, a lot of spare parts. So a pump that provides lower maintenance cost or lower wear of parts is for sure an advantage. And low energy consumption. Pumps are also running quite a lot. Some production are running 24/7, some other only on 2 shifts, but at least 8 to 10 hour minimum of hours running every day, up to, as I told, 24 hours running every day. So the path that provide best total cost of ownership is probably the preferred pump on this application. Some idea of how we can use EVO pump or how we can use pumps actually in in ceramic. One is mold filling. So it's a typical application that is happening in sanitary ware production. So where you have a tank of prepared ceramic clay or slip, the preparation becomes upwards according to the know-how of the single customer. And then the pump is used to fill the ceramic molds and at the end of the day to create the final product. So this pump will run in cycle, the load will be cycling, will be starting, fulfilling the mold, the pressure will build up, then the product is ready to be unmolded and the pump is stopped for a while. And then when the second production cycle restart, the pump will restart with the same cycle, low pressure, and then pressure build up. It's quite, the application is quite similar for filter press, just the product is different. The filter press application is existing in ceramic for many reasons. Could be recycle of waste from molding process, could be recycle of waste from glazing process. So all those products that are creating the finished goods, could be tableware, sanitary ware, or tiles, are generally mixed with water. And when you have the waste and you want to reuse water, the main process that it is used for this purpose is take the waste, the water solution of the waste, pump it to a filter press. Filter press separate the solid part from the liquid part, which is water. Generally, water is recovered and reused in the plant, whereas solid part is generally sent out to a subcontractor, for example, for additional conditioning activities. And again, according to the production cycle, those pumps run with cyclic load, can be run again between 10 and 24 hours, depends on the need of the factory. So what is the EVO solution for this? EVO solution, EVO is a fantastic pump in its working range because provide a lot of advantages in terms of robust flexibility and gentle pumping. It have an heavy-duty design. We tested our pump 25 hours at max load, and now, after few years we have launched, we can also rely not just on laboratory tests, but also on pump in the field, which are running continuous duty 24/7 with very low or no maintenance required. Self-regulating, the pump can self-regulate, so the pressure can adapt automatically to the back pressure required from the system, and the flow can be also set up to a maximum limit, so the pump will reach the maximum flow and then will slow down when the pressure is built up. It has an extended diaphragm lifetime. The diaphragm is completely different and is designed positively for this pump, so it's not like a reusage of existing diaphragms. It's an easy maintenance. Maintenance can be done in place without moving the pump, and no need to dismount it from the line. In addition, we know that the maintenance intervals for diaphragm are very much extended compared to classic air-operated diaphragm pump or other electric diaphragm pump. Low pulsation, thanks to the 3-chamber and the very fine control on torque, we have very low pulsation, which make the pumping style very gentle. And there is a sealless design. Sealless design is maybe less interesting for ceramic in general, but please consider that if there is any other electric technology that is used to move ceramic slip, so those other electric technology, they do generally have mechanical seal that can wear in contact with abrasive product. So this is not existing with EVO because EVO doesn't have any mechanical seal. And it's very efficient. You can see here, there is a chart where you see the comparison efficiency between other technologies. And you see the red line is EVO here, which is far above any other technology, and especially is touching the 70%. 72% is a peak here in the middle, and 72% is considering the global efficiency. So hydraulic, mechanic, electric. So it's the full pumping system. I give 1 kilowatt of power, I receive in the product 0.72 kilowatt of equivalent power into the product. Let's see some success story. Let's start with the one we got in Germany for pumping ceramic sleeve to mold fillings. So this pump is now installed more than 8,000 hours with no maintenance. The picture you see here was just, since the pump was like in a test phase at the beginning, was just a test opening of the pump. And you can see after probably 2,000 or 3,000 hours of works, how, of course, after cleaning a bit, how the diaphragm look like. I mean, it seems to be, it looked like new actually. So very, very well endurance of the diaphragm. Pump is running, of course, very slow because in ceramic in general, to avoid bubbling and to avoid abrasion, we try to reduce the speed of the product. And so running the pump at very low flow rate set point compared to the size of the pump. So 4 bars, 30 liters per minute, running very smoothly. Customer is very happy. It have decreased its maintenance cost by 3 or even 4. The time between maintenance have the time intervals between maintenance have more than doubled, and now is 1 year that pump is running without any issue. So you see here the pump is stainless steel just because there was a certain level of urgency. So we deliver stainless steel. We know that in ceramic generally, the preferred model is aluminum santoprene. So you will see in the next slide, the next case study, it will be a black pump. This was for a filter press application in Portugal. This pump is now running for more than 2,800 hours. Again, no maintenance, no issues. Pump is as a set point of maximum 6 bars, and the flow rate is variable, is completely remotely defined by the PLC of the filter press. So the good advantage is this pump can also be connected to an intelligent, to a smart system, could be a PLC, could be a normal microprocessor, but the pump can be connected to the system and can communicate and follow the system need, which this is also a big advantage compared to some other technologies. The advantage that this customer noted, apart from the extended time between maintenance, which of course is reducing cost, we also see that thanks to the more stable flow and less pulsating, they were able to get a drier cake from the filter press. So customer is now calculating which is the economical advantages of this, but you can understand that if you are sending out a solid part of the waste and you are paying a company to keep this one, and you pay by kilos or by weight, kilos or pounds, but by weight, the less water you have inside, best for you, because the less you pay for the solid part, for the real solid part. Third, the third success story, I cannot be too much detail here because the pump is still under test, but it's still a mold filling in another very specific process. The customer had some difficulties in get the perfect control of fluid, speed, and bubbling effect, and now is starting testing the pump. We still do not have the final result, but the testing is at least showing some promising result at the moment. So let's go to the next part now. We are summarizing the features and benefit of EVO. So just to recap, EVO is a pump that has a very high efficiency work, very low pulsation, leak-free, no mechanical seals or sealless design, as you like to call it, means that you don't have any wear parts that are providing sealing from the wet part to the dry part of the pump. Could be the environment, could be the mechanical systems. So this mechanical seal do not exist. So where there is no risk of wearing this part or need to maintain this part. Easy installation. It's simple to install. You don't need additional base plate or shaft alignment thanks to this vertical layout. And the maintenance can be done in place and can be integrated in the process and full controllable. So with this, as I told you, it was a very short webinar. I hope you enjoyed it. And if you have any question, I open for question now. Or if you have question, if I've already been placed and we want to answer verbally.
Okay, so it's Olof speaking here. So far we have no questions in the Q&A, so please feel free to enter something there. I mean, I know there must be questions regarding this technology. Okay, so let's see. There's something coming up now. I'll try to answer a bit here. Okay, I will take this later on. Like I said, some of the questions will be answered right away, and some we will take just after the webinar. Maybe one question, Thomas, maybe you can answer immediately. I mean, for diaphragms, what materials do we have there, and is there any plan for any other materials except for those available right now?
I mean, those available right now are Santoprene and PTFE. So Santoprene is probably the most adapted for ceramic. There are some. We know by experience that with these two materials, we cover 90% of the business, not just for ceramic, but I mean, in general. There is some project behind for developing additional materials. The answer is yes. But the horizon is not yet defined. It also depends on the need. I mean, if there is a huge need of a certain material, we can expedite one development instead of another.
Yeah. I have another question here, which I can answer. Maybe the question is if it's possible to replace an air-operated diaphragm pump with an EVO pump, and the answer is yes, definitely. I mean, it's a very, very good thing to do here because the efficiency, of course, will go up, like Thomas has shown here, a lot, and so the cost of energy will go down with this pump, with this technology. And also the maintenance with this pump, the cost of that, and also the downtime of the system will be so much lower with the EVO pump, up to maybe 4 times than you have with an air-operated pump. So the answer is yes.
It looks like there is no question anymore.
No.
Okay. Thank you very much, Thomas and Olof. Thank you, everyone, for attending the webinar today from ARO. You can scan the QR codes here in the next slide to visit our website to learn more, to complete our contact form, to have someone contact you, and subscribe to our YouTube channel to rewatch this presentation and other videos from ARO. Thank you again, and have a nice day. Bye.
Thank you. Bye-bye.
Thank you. Bye.